Welcome to this other session of Kurgateric Finance and Accountancy Tutorials. Today we're still moving on with trying to solve this question, KASNEB June 2011 question 3C on transportation problems. So far in our previous sessions we've looked at solving this particular problem using Vogel's approximation method and the northwest corner rule. So today we are going to look at the last method of solving this transportation problem, and the method is the least cost method. This is the simplest method of all. It's not like the Vogels and the northwest corner rule. So this one is just direct, the least cost, and then you allocate as much as possible and you're done, right? So but before we do that, if you are not subscribed to the channel, please do so, and give this video a thumbs up, and also you recommend the channel to your friends so that they can also benefit from these free tutorials. Make sure that you hit the notification bell so that you don't miss out when I upload a new tutorial. So for returning subscribers, welcome again. So without much ado, let's move to this question. You solve using the least cost method. So still we are going to create our own matrix from this information, and then we try solving it using the least cost method. So still we are going to say that this is from the warehouse number 1, warehouse 2, and warehouse number 3. Then you have customer 1, customer 2, and customer number 3. Sorry, we still have to write demands and supplies. So you have customer 1, customer 2, and customer 3, and then you have supply here, and then you have demand on this other side. Then you draw as such. Now that we have our own matrix, we can draw it. Don't mind my drawings. So we have the costs being 100. So we have 100, 80, we have 120, 140, 80, then 140. We have 120, sorry, 160. We have 160. We have 120. And then you have 140. The demand being for the customers is 280, 280, then 120, then you have 200. For the supply from the warehouses or the sources, we have 260, 260, we have 168, then we have 172. So when you add the total supply and the total demand, they all meet at 600. Are you together? So this one, ladies and gentlemen, as I had told you earlier, this is the simplest, the least cost. This is the least transportation cost. So these are the costs in here: the 180, 172, 140, 80, 140, 160, 120, and 140. So these are the costs. Now we are supposed to identify the least cost in these costs here, the transportation costs here. So the least, or the smallest, I can see here from my case, from these figures, the transportation costs here is 80, but there is a tie of 80, 80. So when there is a tie, you take either. So since we have 80 and 80 being the lowest or the least cost, now we are going to allocate as much as possible to one of them. So either, we are going to take either. So in this case, let me just take this one, the first one here, the warehouse 1 and customer 2. So when you have identified, now you draw as such, and then you allocate as much as possible to this least cost. You allocate as much as possible to this least cost. Now that we have in warehouse 1, we only have 260 bags of rice. but this customer under this column requires 120 of rice, isn't it, or bags of rice. So we are going to allocate the 120 because you cannot allocate 260 and the customer requires only 120. So we are going to allocate the 120, and then we say now that 120 this customer is satisfied, and then you remain with 0. And then you say minus 120 here, you remain with around 140, right? 140. So this customer is satisfied. Now you do what? You cross this column, the least cost method. Are you together? So the next step is to find the next least cost. Which one is okay from the remaining ones? So the remainings are 100, 120, 140, 140, and 160, 140. So the lowest is 100, isn't it? You allocate as much as possible to 100. That is how simple this cost is. So here we only have in warehouse 1, the remaining is 140, but this customer requires 280, but you cannot give more than what we have. So the warehouse 1 is only 140, so we allocate all, and then you say minus 140, you remain with 0. Right together. So you come and give this person 140, so we remain with 140, isn't it? So that means this row is done because we don't have anything to allocate from the warehouse 1. Now you cancel it off. Do you see that? So next step is to find another least cost from the remaining. The other least cost is we have a tie of 140 times 3. So you take either. So let's take this one. Having identified, you just allocate as much as possible to this cost. So this warehouse 2, right? Then customer 1. Customer 1 only wants 140 in this warehouse 2, but we have 168. So we are going to give this customer whatever he requires in full. And then you come here and say 140 is equal to 0. You minus 140 here, you remain with around 28. Right? So this customer is satisfied. It's 0. Now you cancel off. Are you together? So we are only remaining with 160 and 140 for warehouse 1, customer 3, and warehouse 3, customer 3 respectively. Right? So we just do the normal that you are going to identify the least cost between what is remaining. So these are tie. You take either. So in this case, let me take this one. So this is warehouse 2 for customer 3. In warehouse 2, we only have 28 bags of rice, but this customer 3 requires 200. But what we have is what you are going to allocate in that warehouse, right? So 28. So that means when you less 28 here, you remain with 0. We are done. And then you come and say 28, you minus 28 here, you remain with around 172. Isn't it? So since this row is done, then you close it because the warehouse you have nothing. And then since we only have 172 in warehouse 3 and this customer 3 requires 172, then it's balanced. You write 172 and then you cross. You say minus 172 is 0. You say minus 172 is equal to 0. That is how simple the least cost method is. So the next step is for you to find the total cost, the total transportation cost. Therefore, total transportation cost will be for warehouse 1, customer 1, warehouse 1, customer 1 is equivalent to 140 times 100. I mean the 140 allocated and the cost is 100 per bag. So such. And then next is warehouse 1, customer 2. Warehouse 1, customer 2 is 120 times 80. Right? And then next is warehouse 2, customer 1. Warehouse 2, customer 1 is 140 times 140. And then next is warehouse 2, customer 3. customer 3, warehouse 2, customer 3 is 28 times 140. Then the last one is warehouse 3, customer 3 is 172 times 140, right? So this is 24,080, and then you add, yes, so that you get the total transportation cost. So the totals will be 14,000 plus 9,600 plus 19,600 plus 3920 plus 24,080. The answer is 71,200. Are we together? So ladies and gentlemen, that is how to do or rather how to solve this kind of a transportation problem using the least cost method. So it is as simple as that. So I want to believe I've done justice to the least cost method, and in more so I've done justice to this problem that was examined in June 2011 by KASNEB, isn't it? So if you have not understood what something here that we've discussed today, make sure that you rewind this tutorial as much as possible until you get to understand. So you should not fail this one in future, isn't it? So make sure that you also recommend the same to your friends so that they can know that there is this channel on YouTube that you can benefit for free. So ladies and gentlemen, that is all about transportation problem. So in our next session we are going to look at the linear that other special type of solving the linear programming problems, and that method is known as the assignment method. So let me not go into detail to that because we are going to look at it in our next session. So until next time, it's goodbye for now. Subscribe.